Recently I found a Pentium 4 3 GHz processor and 4 gigs of RAM in a system abandoned somewhere outside. I'm going to build my dream computer with it soon, if it works. I had this dream like 20 years ago when the Pentiums were just rumored to come out, the Pentium 4s with hyper-threading. Oh boy, all the DOS games will work perfectly. Yeah, that was the dream, and hopefully I can build it. Back then, I had to settle for AMD because I didn't have Pentium money. So yeah, hopefully I will do that and have a Pentium 4 to run old stuff. But today I want to talk to you about this ratcheting screwdriver, which has something to do with computers because this is what you use to assemble them, maybe scratch them and ruin them, but I thought it was interesting. The mechanical part was falling apart, so I took it, disassembled it, and saw that it's quite genius. First of all, it's bad. From a usability standpoint, one click is almost like a sixth of a turn, so it's not very comfortable to use it like this, I think. But yeah, I want to show you the solution they came up with. It's quite genius. You switch it from here. In this position, you're unscrewing, blocked, and screwing. And as you can see, not very many clicks. That's kind of annoying. But yeah, I think the mechanics are quite interesting. So let's take it apart. You just unscrew this piece of plastic that basically holds the middle part centered. You push this in, or oh yeah, you have to push it in a little and it comes apart. Come on. Or maybe you press it there and then push it. Yeah. Okay. So the ratcheting mechanism is here, but on the back I just want to show you this little piece that holds the that holds the shaft from falling out. Not really necessary because other stuff is holding it too, but yeah, I think it's a good choice to have. This is a casting. I don't know what it is, but doesn't seem too solid. Maybe aluminum or some yeah, something else maybe. Something, yeah, maybe aluminum. Whatever. So, let's look at the the ratcheting mechanism, which is quite ingenious. It has, this is just a spring that pushes on either this part or this part. So, in this position, it's locked. When the spring is pushing in the middle. If you push it upwards, then it releases this part and the thing can spin in one direction. And not the other. And when you push it down, it lifts the other ratcheting thing and can spin in the different direction. Yeah. So basically just to... Oh, and they are identical? No, not identical. But it can be designed to be identical. They made it slightly different. I don't know why. There's no real reason for it. Yeah, it's Yeah, I guess it makes sense, but you can make it symmetrical to simplify manufacturing. So this and this, yeah, kind of primitive. I didn't even count all the ratchets here. What do you call them? The teeth. So it's 2, it's 10. So not even 6, 10. That's kind of okay, I think. 10 steps to make a full turn. Well, yeah. But the problem is that the mechanism is not really precise. You have to turn it a lot and then it comes back a lot. So that's my discomfort when using it. Yeah, I didn't even think about that. That's the problem. It's not the number of steps, but the actual mechanism that moves too much. Yeah, the LTT screwdriver probably has this beat. This is kind of bad. Okay. Guess the price after you saw the construction and the parts and quality and whatever. Guess how much did this cost with 4 bits? It had 4 bits. I don't know where I put them. 4 small bits. 2 Phillips and 2 flathead, I think. No, Phillips, flat. Yeah, whatever. It had something. 4 irrelevant bits. Because you need a lot of them. When you work too much, you need a lot of them. So let's reassemble it with the button. This is symmetrical. And the spring is symmetrical, luckily. So come on. How did I assemble it last time? It's too late at night. That's the problem. Yeah. You need precise movement to assemble something like this at night. Or, yeah, it's morning already, 7 a.m. But, yeah, with no sleep, you just put this on. There's a thing here that has to meet that other thing. And you just push it in, push it on, and hope for the best. Like that. Come on out. How did I do this last time? Like that. Just like that. And it works. Kind of primitive. But when you really need it, for $2. Yeah. I was stuck at the price. I didn't say the price. $2 for this screwdriver and 4 bits. That's instantly usable for Phillips and flathead. So yeah, let me just compare it to this. I've also one of these. Oh yeah, this is much finer. This has at least 24 teeth. 24. Unfortunately, this can't be locked. So, one way or the other, it can't be locked. Or can it? No. Yeah. This was also quite cheap. Like, it was a huge set for $10. All sorts of screwdrivers and screwdriver bits and what do you call them? Tubular bits and stuff. And torques and stuff. But yeah, I like this much more. I want to get a screwdriver that has this mechanism. It's from Parkside. It's sold here in Kaufland and Lidl hypermarket chains. So yeah, I took a chance on this. It basically has no brand. It's the specific chains brand. It had a simple, very simplistic box and only the 4 bits. And you get what you pay for. Usable, but kind of crappy. Ingenious design, but crappy. I like the engineering thinking behind this, but it's crappy. So yeah, I want one of these in one of these. So yeah, if you care about tool quality, don't buy $2 worth of tools. Buy something that's at least 10.